I'm really excited to have Mary speaking here. I came across her in a news story I read about some conference in Hungary or somewhere. And it said, wow, this person, Mary, gave this great talk about microservices. It was amazing. It was not full of BS like so many of these microservices talks are. It had some real thoughtful stuff in it, with opinions of people I very much respect in this industry, saying that Mary was this great person. So as one does, I looked her up on Twitter. Again, sign up if you don't have an account, Velocity. So I looked her up, and I saw, wow, she lives in Eden Prairie. This is awesome, because I live in Eden Prairie. So I'm like, wow, this like software luminary who I didn't realize existed, lives here in town with us. I'm super excited about that. So there's another conference series I also help with called Mini Analytics. We were able to get her to come speak there a few weeks back. Now we've got her speaking here. And if you've ever heard of this thing called lean software development, that's her term, her and her husband Tom. So they literally wrote the book, and then they wrote like 3 or 4 more books after that. So I'm very pleased to have her here. Thanks. Mary, come on up.
And good morning, everybody. So in 1986, there was an article published in Harvard Business Review called The New Product Development Game. It was January 1986, 30 years ago. So it was new 30 years ago. And based on that article, about a decade later, which would be 20 years ago, the first discussion of Scrum happened at Uppsala's. And perhaps 5 years, perhaps a decade later, in 2005 or 6, Scrum and Agile in general crossed the chasm and started to become the thing that forward-looking companies did. And by now, it's been around for a pretty long time. And what's happened, if you think about 2006, there was no cloud. Smartphones maybe existed, but there wasn't a concept of apps. So that was only 10 years ago. And now, what we have is, I don't have my clicker on here that I didn't test, so we have to put it in. And hopefully it works. Try that one. Software is eating the world these days, at least according to Mark Anderson. And really it is. If you take a look at the great big unicorns out there, the Googles and Facebooks and even all of those kinds of folks up there, even you can look at Dropbox and you can look at Netflix and you can look at Spotify, and they're doing some amazing stuff with very large software bases, and they're being very reliable. In fact, when healthcare.gov had to be rescued, who came and rescued it? So Mikey Dickerson from Google, he was a reliability engineer. You know what a reliability engineer? An ops guy came and led the team that sorted it out in about 6 weeks and got it started. And because they understood how to deal with very large code bases that did all sorts of interesting things, how to make them reliable, how to make them secure. And it wasn't put it all up on one day on October 1st. So if you take a look at how do we deal with these very large code bases, because in the end, if you're going to do anything that's exciting and useful, your code base will get large and complex. And I think that the 2 things that you have to think about are, still isn't working. The 2 things that you have to think about are how to lower friction and how do I limit the risk of what I do. Now, you understand how to limit risk. Okay, everybody worries about risk. But there is another piece to very large code bases that you have to pay attention to, and that is lower friction. So let's talk about friction. So friction, I think, would be the large system disease that we all have to deal with. And it's not just in software. In fact, if you look at von Clausewitz's discussion of war, that's where the first time the use of friction came in, where he starts talking about it's the concept that describes the thing that makes war different in reality than on paper. Because there's all of these individuals that all have friction around them, and then you add chance to that, and nothing happens the way it's supposed to happen on paper. So I want to show you a picture about friction. This is a ship, and not that long ago, 60s and 70s even, the way goods got from one spot to another was to be loaded on pallets, and the pallets loaded into ships, and all those individual things, in theory, would get unloaded and get, sent off. And tons of longshoremen, or I think it was what, pardon? Stevedores, right, in the UK, had jobs that did that. And huge economies depended upon it. But what you got is that the flour things would break and stuff would leak and little mice would get in there. And there was, the whiskey coming from Scotland would get somehow disappeared. There was a huge amount of loss in those ways. And so you have a very large amount of friction here. And in this high friction environment, I'm going to give this one more try and see if it's going to work here. So you have a very high friction environment, and eventually people figured out how to deal with that by creating containers. And now you can put all of that whiskey from Scotland into a single container and lock it up, and it makes it all the way to the destination with no loss and no mice and no other things that steal it. So this creates a much lower friction environment. If you want to read more about this, this is a truly interesting book. It's nothing to do with software, but everything to do with how you think about how you create less friction in the history of how our whole economy changed and became a world economy through the use of lowering friction through containers. So let's talk about what I'm going to talk about, which is the complexity game. So we create complex systems. What games do we have to play now today, not 10 years ago, not 20 years ago, but today, in order to make sure that our complex systems are secure, are workable, are responsive, do what they're supposed to do? The two things you have to think about is how do I lower friction and how do I limit risk? Okay? I'm going to talk about architecture, about engineering, and about organization. So let's start with architecture. When I was working at 3M, we knew for sure you had to have this great big database that contained all the corporate information so that across all the divisions you kept track of all your customers and stuff like that. There was huge efforts in the 90s to centralize all the data concepts so that they were accessible to everybody, and that was going to make their business so much better and so much. The problem with that is that when you have a single database, what you've done is you have coupled every single bit of code out there in the whole company through that database to every other little bit. You have created a massive coupling mechanism. And so you get deep dependencies all the way through the database and very high friction. It never occurred to me that this was a problem, but it has occurred to some other people. And when you think about it, the thing that changes that architecture today is called microservices. Kind of a new concept. But when I first heard that Amazon.com had all of these little services, and the services had their own database and they didn't have a central database, I thought, how could this possibly work? And you might think too, how could this possibly work? Well, it does. It does because it uncouples all of these little things, and you have what I'll call a federated architecture, so that you have independent states sort of doing their own thing with their own data. And so you have much lower friction. And if you think of this concept, when microservices, if you think it's interesting, I really recommend you read this book. It's amazing, by Sam Newman about microservices. And what you get in through the whole book is we have to stop having dependencies between our software and between our software teams. And so what is a microservice? It's a little service. It does something, and it does it well. It's independently deployable, okay, by definition. So the size depends on what is the chunk that can be deployed independent of everything else, preferably as small as possible. And it is managed by a small team. At Amazon, they call a small team a 2-pizza team, a team you can feed with 2 pizzas, 8 or 10 people. And that team does everything, end-to-end responsibility. Okay, so you don't have product here and ops here and testing and development in the middle or any of that. You have 8 to 10 people that deal with the whole stream, day, night, weekends, 24 hours a day. It's their problem as a team. And they make their thing work. The other thing is, if you build it and you're on that team, you monitor it, you deploy it, you fix it, you decide what it's going to do. So the whole team has team responsibility for this small service. The typical practices you see with microservices, again, it's spreading beyond the unicorns, although they're the ones that started with it. There are no central databases because databases couple. There's extensive automation and monitoring. I'm going to talk about this later, double mock contract testing, smart versioning services, canary releasing. I assume you know what that means. So just do a release to a very small portion of your audience and figure out if you have any problems. After you've done your testing, hopefully not, but it could happen. So Beth Shuri of realestate.com in Australia has talked about double mock testing, and they're doing microservices, but perhaps the leader in this area would be the way Amazon started it out and then was able to sell their infrastructure. They're making about $1 billion a quarter on Amazon Web Services. So the stuff works, and if you get it right, it can make a lot of money. Netflix does it, Spotify does it. I went to a talk in Budapest at Gilt, a company that basically says every noon we're going to have a sale. So they structure their entire business so they totally flood their website at 11:55 a.m. Eastern Time every day of the year. And they have to deal with that kind of volume. So microservices are things that companies with very high volumes have tended to go to. But, we've heard this story before. Objects were going to save the world too, right? And what's to keep us from having dependency hell when we have all these tiny little microservices? Because we never quite managed to break free of all of our problems with objects. How are they any different? Well, if you're going to think about how do we do this independent deployable stuff, the first thing you want to understand is whether or not microservices work in your domain. And I will say that from what I hear, any area that has massively high volume absolutely ends up going to microservices. So they seem to be demanded in high volume traffic areas, and what they do is they're deployed along the pipeline so that as the pipeline constricts in any area for the high volume, that area can be handled independent of any other area. The second thing is you would never use microservices until you understand your domain. So very typically, a company will move from a monolith, which is not a bad thing, it's the way to start, to microservices after they understand their domain. You have to get the bounded context right. Martin Fowler, who's writing a lot these days and has some interesting blogs on microservices, says that it's really not so easy to refactor microservices once the lines are drawn on the borders. So you want to get those right before you get the services, because refactoring becomes difficult between services when you have independently deployable things. And the other thing that microservices demands is a lot of discipline, very strict discipline. You cannot talk to any other service except through hardened interfaces. You can't have a path through the database where you change information. There can only be one well-known path. And the teams that have responsibility for microservices maintain what I'm going to call situational awareness. They keep track of how is my thing performing? Is it going down? Okay, now suddenly everybody on the team has to worry about this 24/7. The consumers. Do I provide my consuming services with what they need? Do I provide my customer services with what they need? And I maintain awareness at all times because I'm deploying a lot frequently, maybe every couple times a day, certainly a few times a week. And I'm deploying independently. When I deploy, am I doing anything to harm anybody? As we have a spike in traffic, what happens to my service? We have to all on our team pay attention to that. So enough about microservices. There are other things that you can do to deal with lowering risk and limiting friction on large systems. The next area I want to talk about is engineering. So I'll talk about, given whatever architecture, whether it's monolith or microservices, one of the things that you can do to create a way to get a handle on big code bases is to pack things into containers. So we've done this sort of with virtualization, where we create a couple of layers and put virtual machines on top of servers. And what happens with Docker is we create a whole bunch more containers that fit on my ship, my server. So we have a massive improvement in server utilization, and we just have a different kind of virtualization, much improved. When you want to think about a container of any type, and you have a monolith, one of the things that I've seen happen pretty successfully is that you start with an important module in your big system, and you say, okay, how can I grab all the dependent pieces for this module, put it all in the same container, figure out how to make all of those dependencies work, and then repeat and refactor to make sure my containers stay small. So why containers? Well, because just like shipping containers, you build them once and they run anywhere. They give you consistency of configuration. They give you isolation. So if you kill a container, you only kill what's inside of it. They're easy to use, at least Docker containers. They have a whole bunch more apps. And one of the nice things about containers is that because they're open source, there's a huge amount of improvement, constant improvement on their capabilities. So they lower friction and they limit risk. But we do another thing in our software world, and that is we think hard about how to make life successful for other software development. We have a policy in the software development world that whenever we come up with a good idea, we make it open source so everybody can use it. And because of that, just like in the academic world, all of our good ideas become public through Git or GitHub or open source in some way, and we build on it. If you look what's going on in the big data world, Yahoo starts with the space, and Google puts something on top of it, and Netflix goes on top of that. And it's all through the fact that this stuff becomes open source, and we build on each other's knowledge. There are not that many industries in the world that do that. There's all kinds of folks that think proprietary is the way to become differentiated. And it doesn't work in our world. And instead, people share. One of the interesting things that was shared with us in Australia by Beth Sherry is when I have microservices and I deploy independently, I gotta know that I'm not gonna hurt anybody else. And in the old days, when we deployed in bigger chunks, we had ways to test where we have a request and response, and we create a mock. And we test our requesting service with the mock. But what we don't know if we've got microservices and our whole system downstream is changing all of the time is, does that mock actually resemble the way the service is today? Because people have been changing. So the concept here is, okay, let's think about that. I create a mock, and then I create a thing that Beth calls packed, which basically takes my mock and says, okay, system, I'm going to make a mock and see if the system works the way that my pack thinks so. So then you create a second mock, which comes from your packed, which says, I'm expecting the system to behave this way. does it really? And you run that mock and decide whether or not the thing works. So you don't get rid of all of the defects with lots of independent deployments this way, but you get rid of a ton of the defects with independent deployment this way. So mechanisms, very sophisticated mechanisms to limit risk occur. So Beth invented this probably a year ago. Put it up on GitHub, talked about it in Australia at the YAL conference in December. Lots of people are using it now. That's what we do in software. We share our good ideas so that everybody can use them. Now, not all of you are going to have microservices. Facebook doesn't have microservices, for example. You don't have to have microservices. But if you have monoliths, you still have to figure out, how do I make sure that they are reliable and repeatable? How do I lower risk? How do I lower friction when I have any kind of service at all? And you know, we actually know how not to do that. And this is how, for any complex system, this is the way to be sure that it fails. You smash it. Yeah, give it one great big punch, and all bets are off as to the way that it's going to respond. That's complexity theory. Anybody in the complex world understands that when you smash something that's complex, you don't know what the response is going to be. You can't predict it. That's what friction does for you. That's what chance does for you. So we have been smashing our systems with these, you know, yearly or 6-month or quarterly deployments, or let's bring everything up all at the same time on October 1st concepts for a long time. We have to get over the idea that this is a good idea, that this gives us reliability, that this gives us guaranteed success, this gives us guaranteed failure. That's what you get when you do large releases. You're smashing a system, you have no clue what's going to happen, and you never will. So the other thing we know for sure is that there is a way to reliably update complex systems, and this is what it looks like. Okay? You poke it, you see what it does, and you fix that or respond to it, and you poke it again. So we know this, okay? Anybody here that's ever worked in the software world gets the idea that this is the way you deal with making complex systems secure and reliable and repeatable. This is what you got to do. And, you know, about 5 years ago, this book came out that said, okay, even in enterprises, we can do that. It's called continuous delivery. And if you're not doing continuous delivery, you got to wonder why not, because it gives you more reliability, more security, and it works whether it's a monolith or not. So if you look at what Jez Hempel talks about when he talks about continuous delivery, first of all, you have to have an acceptance test-driven development process. This is not optional. So tests are not there to test. Tests are there to specify what it is the system can do, so I can be sure that it constantly is continuing to do that. You have to have tight collaboration between customer-facing and delivery people. They have to work very closely together. Even if they're not on the same team, they have to act like they are. You have to have cross-functional teams that include product, QA, ops. Okay? None of those are optional. We talk a lot in this session about devs and ops, but where's product? You have to have automated build, testing, database migration, deployment, and so on. You have to have incremental development on the main line, on the trunk. If you are branching, you're not doing continuous delivery. Branches are not part of it. They're not good anymore. You're always deploying to the trunk. Now, you're not necessarily deploying something that customers can see. So deployment is separated from release. Release is done by a switch. If I'm not done with it, I just put a switch on it and turn it off. And then when I'm done, I turn it on. And that's a release. Deployment happens all the time. So the code is always on the trunk and always going into development all the time, every day, in small pokes. Software is always production ready, and if it isn't, everybody's top priority is to get it there all the time. Not features, but get the thing, make sure the trunk is production ready. And releases then are tied to business needs, not to operational constraints. So continuous delivery is been around, and starting when it was new in 2010, within months we started seeing companies do this. And today in our workshops, easily half of the people or more in big and small companies around the world are either there or heading there, and more and more. And if you're not, you got to ask yourself why. Because if you're not doing small pokes, you don't care about stability, you don't care about reliability, you don't care about predictability. This is the way to get it. This is not dangerous. You would think it would be. But it is specifically the least dangerous approach to software development that there is. So let's go into the one last part, and this is about organization. I'll kind of whip through this a little bit fast, but I started a little late, so I might go a few minutes late. And here, I just want to talk about the fact that devs people and ops people are different. I'm not going to talk about what is devs and what is ops. I'm going to talk about the fact that there are kind of two kinds of people in the world. And if you want to read more about this, get this book on focus. It's by, well, it's here. That's right. Troy Higgins and Heidi Helverson. Very interesting stuff that they've been doing. And they talk about this idea of regulatory focus. So in this scheme, there are two extremes of kinds of people. You know, you'll fall somewhere in between. But there are people who worry about safety-focused goals and people who worry about aspirational goals. So if you are in the safety-focused world, you want to prevent failure. You want doctors and nurses to prevent failure, people who do power plants to prevent failure, people who do ops are worried about preventing failure. You're looking for the safest option. But if you are in the promotion-focused goal, it's all about let's try stuff. Let's do something new. Let's try every option there is out there. So these folks are inspired by duty and obligation if you're in the prevention-focused type of person. And people in the promotion-focused type are aspirational. And so how many here would consider themselves to be more safety-focused? Okay. And how many more, let's just try it, kind of aspirational? So I'd say a little more than half on the aspirational side, a little less than half on the safety side. And they're both very good. We got to have both of those kinds of people in the world. In fact, they say that oftentimes in a marriage, you'll have one of each. And it works as long as they're working for the same goal. So what we typically have is devs folks tend to be like me in that aspirational side. I'm going to try anything. I really don't care about being safe. And then there's the folks that really do care about being safe. Typically, the ops folks care a whole lot more. And what you get then is a deeply sort of gut in your personality tension between the two. And I think that has as much to do as organizational policy with why it's sometimes hard for the two groups to work together. So what do you do? Well, everything about this has to do with you have to share a goal. And if you share a goal, it's not so bad to have both perspectives on the team. So you need a shared goal. You need to say who is responsible, for example, for customer satisfaction. Oh, that's the business, right? Or that's the product guys. Or that's the engineers. Or that's operations, whatever. And anybody but me. Yeah? And that's not a shared goal. You have to say we work together. Nobody succeeds unless everybody succeeds. And then all of us are responsible. Then you have a way for the two different personalities to share responsibility. And so I want to get back to this concept of situational awareness. This is a book called This is Lean. It's by Nicholas Modig and Per Angstrom from Sweden. And it's a wonderful book. Again, it's not about software, but it's really cool. And in it, they talk about, see, Nicholas spent time in Japan working with a Toyota Sensei that was his sort of guide in how does Toyota think about doing stuff. And in the end, he showed Nicholas this picture of a football field. You might call it soccer, but I spend too much time in Europe. I have to call it football. So this is a football field. And the question is, what creates a top-notch football team? You know, the kind that won the thing in Canada last Sunday. What is behind a really good football team? What do you do? What do you think? Pass? Good passers? Anything else? Strong legs? Speed? Great players? Field position? Teamwork? So, of course, this is a Japanese sensei, so nothing Nicholas said was right. Okay, got it? And that's the way it works. So he said, okay, so what makes a great team is everybody on the field is aware of everything all of the time. They know where the ball is, they know where their teammates are, they know where the ref is, they know what the score is, they know how much time is left. Every single person maintains situational awareness of the goal and the game and all of the people around them. And the team with the most situational awareness wins. Wayne Gretzky was saying, I skate to where I know to where the puck is going to be, not to where it is. And people watching him said he spent huge amounts of time watching and understanding and knowing where the puck would be, and then he'd be there. It's situational awareness. And all too often in our companies, this is what we have. We have our tents here, and we think if we kick the ball out of our tent, we win, right? And we cover up the scoreboard with advertisement and that sort of stuff. So this does not win games, nor does it win competitive situation at all. So we have to figure out how to create an environment where everybody is aware at all times of the high-level goal. And because I am now out of time, I am going to say that's sort of it for today, and thank you very much.
Thank you, Mary. That was amazing. And we are unfortunately running a tiny bit late, so we probably should not do too many questions, but I feel like if we don't allow one or two, everyone will be super sad. So a lucky questioner or two can ask Mary about more details.
There's one back there. Pardon? What did I say what? Well, I just read that a day or two ago by somebody.
Can you repeat
So
the
I
question?
am relying on hearsay on that. Why do I say Facebook doesn't use microservices? Because I was reading just 2 days ago an example of, yes, you can live without microservices. For example, Facebook doesn't use them, and they're quite all right. And so that's why I said so. I could be wrong, and I can't give you the reference. Pardon? But if the teams are not deploying independently, it's a microservices. PHP might be a microservices tool. But to have microservices, you have to have independently deployable services in the world, in practice. Otherwise, it's not microservices. You see? So there are plenty of tools that support this, but does it happen in the wild is the real question. And probably the most famous is Netflix, who kind of pioneered this and has open sourced all of their work in it. But there are many, many followers these days.
Okay, I think that's probably what we have time for. Thank you so much, Mary.
Thank you.
Wow, that was awesome.